All right, welcome and thank you for joining me on this webinar, Introduction to Kiuwan SAST, Static Application Security Testing, and SCA, Software Composition Analysis. My name is JD Burke, a sales engineer with Kiuwan, and I bring a broad range of subject matter expertise and experience to today's webinar. Software development, software project management, hardware testing, software testing, network ops, and some business integration consulting. This webinar is designed for QA personnel and information security personnel, practitioner to manager, but with no expectation that you have any experience with SAST, SCA, or Kiuwan. So a little bit about the agenda for today. We'll talk a little bit about us. I'll go over a brief overview of SAST and SCA. I'll actually take you into the Kiuwan tool and analyze some code and step through some of the results. And then we'll go into that Q&A session at the end. So we have a lot to cover, so let's get to it. Kiuwan is a global company providing an end-to-end application security platform to bring objective data and facilitate informed discussions regarding the cost, effort, activity, quality, maintainability, efficiency, and dependencies of your organization's applications, software applications. Kiuwan is a member of the Adira family of DevOps tools. You may know that better as the products called TestRail, Assembla, Ranorex, and Travis CI. By the time we're done, you will have seen how to introduce Kiuwan to your application. We do that by creating a new application, for example, hello world. You can set some metadata options about that, save that off, and then analyze your source code by clicking on one of the Analyze buttons. We use a downloadable analyzer because of our hybrid cloud model, but for today's demos, I'll just be uploading a zip of the code and doing all of our work that way. And then once we upload the zip, Kiuwan will analyze that, give us some kind of initial feedback on what it found in that zip as it unpacks it and then starts to do its analysis. And then we can set some parameters to guide the analysis and then run the analysis. And then once we start doing that, eventually we'll come back with a completed analysis where we'll see an overview of the results for both SAST and SCA. I should mention that there are two things really to note here. One is that we are this hybrid cloud model that uses a downloadable analyzer that you can bring onto your domain to analyze your code, and then you upload the results file for us to augment. And the second thing is that today I'll be using some well-known bad applications, so DVWA and WebGoat, which are applications that are readily available out on the interwebs that has specifically been built to have bad coding practices in them so that you can practice with them. The other thing I would point out is that when and if you choose to take Kiuwan for a trial on your own code, and maybe you use it against some of your existing tools that you use for SAST and SCA, I would encourage you to come back to things like DVWA, WebGoat, and the other benchmarking software packages so that you can do a head-to-head between Kiuwan and anybody else you might be comparing us to figure out who is going to serve your SAST and SCA needs the best. So continuing on, I'll also show you Insights, which is our, let me log back in again, is our SCA product. We'll go over some of the information that it's brought back in our SCA offering. And then I'll spend some time creating, when we get an analysis back, creating what we call an action plan to curate the list of vulnerabilities down into a to-do list so that you can actually push that forward to your tools and assign that out to developers to work on. We'll spend some time creating our own action plan using our what if tool and the various ways you can analyze your vulnerabilities to intelligently come up with a shorter curated list of things to do, and then save that action plan off, and then from there manage the workload from the completed action plans by pushing it forward to whatever task tracker you use. All right, so now we'll switch back over to set up for more of an online demo. So to start with, let's make sure we are comfortable with some terms here. So Kiuwan is a SAST tool. SAST, for those of you that don't hang out in the security application testing world, is a source code analysis concept where you analyze your source code and in search of security flaws. In a more holistic, big picture kind of way, SAST lives over on the left end. So it's one of the leftmost security reviews done by software in this linear SDLC model, as opposed to DAST or IAST, unit testing, pen testing, etc. Kiuwan does both SAST and SCA, but it has some artifacts that it delivers to these other blocks. But it does not do, Kiuwan does not do currently any of these other items like SAST and DAST. I'm sorry, DAST and IAST. Your source code is analyzed for coding patterns in the SAST models and SCA models, known to be security weaknesses or vulnerabilities. And that's as defined by the various standards and organizations that your organization may care about. So Kiuwan is aware and checks your code for normatives and frameworks like you see on the screen now. There's some more than 12 and more than 25, more than 12 standards and more than 25 frameworks. Once those vulnerabilities are identified in the source code, they can be managed, either by changing a specific line of code, by jumping into the IDE, using one of our plugins, and, or muting. So from time to time, you will, in this long list of vulnerabilities, have other reasons to mute and skip over a given vulnerability. Or with our action plan concept, where we take the items that are to be worked and push them into an action plan that can be sent out to your task tracking. Another way you can manage this, sorry about that, is with compensating controls within your ecosystem. For example, you may know that you have vulnerabilities in your source code, but you may choose or may determine that the best way to mitigate or handle that risk is with compensating controls on the right side of the pipeline, for example, at your SOC level. Similar analysis techniques can be used for third-party and open source components. It's code you use that you or your organization may not have the rights or the source code to modify. You might know those components as OSS, or open source software, and the analysis as software composition analysis, SCA. The coding patterns that SAST and SCA tools scan for are what you might know as SQL injection, cross-site scripting, OWASP top 10, maybe CWEs or CVEs, depending on your shop. Kiuwan refers to them as these. These are just examples, but they all map to some of the slang that we were talking about earlier, and the normatives that I showed you earlier, like the OWASP, OWASP-M, PCI DSS, etc. Kiuwan is a hybrid, cloud-based SAST and SCA tool. So it's a SaaS with augmentation engine and results database with a downloadable on-prem source code analyzer. The basic analysis of your source code is loaded into our cloud analytics engine for augmentation and analytical post-processing. With our hybrid cloud model, you can deploy the Java-based analyzer across your organization. That Java-based analyzer, called Kiuwan Local Analyzer, or KLA, gives you flexibility about how much of your source code will be uploaded to the results database with each analysis. For the TestRail users in the audience, one of the big benefits of Kiuwan is that you don't need special security expertise to scan your code and find the security vulnerabilities or the quality issues. We are quality ISO 25000 type folks, and we tend to live and come from more of the left side of the pipeline, as opposed to some of the tools you may have been exposed to that are coming at you from the right side or the security side. In addition, if you want to see how Kiuwan works for your applications, TestRail users, and any others out there, we offer a free trial. You can also purchase a one-time scan to do one-off audits of your code. As I said, our dashboard gives your organization a view onto your source code that not only includes security aspects, traditional SAST and SCA, but also from an ISO 25000 point of view. So ISO 25000 is also known as SQUARE, or the software quality pillars of efficiency, maintainability, portability, reliability, as well as code security. You'll see as we move through the Kiuwan tool that our 15+ years of software experience give us a better DevSecOps view on the pipeline than the information security teams may normally get from the security appliances living on the right side of the CI/CD pipeline. This becomes more important when security types are trying to talk to the developer types, and the developer types are trying to understand what the security types are after. All right. So recall we uploaded, when we started, we uploaded a zip of source code into Kiuwan, and I told it to analyze it. The actual analysis is done by telling Kiuwan which Kiuwan rules to apply when you perform an analysis. So if you're an information security type, you might know the concept of rules as being similar to a virus signature, or the pattern that we're searching for in your source code. So when we uploaded that code to start our analysis, the definition that we used called for a series of rules to be applied to check for patterns within our source code. Those rules are bundled together in a logical container called a model. Kiuwan gives you more than 4,000 rules by default to cover those 33 languages, more than 33 languages, more than 12 normative standards like the PCI, DSS, OWASP, CERT, those that I showed you earlier, and more than 25 software frameworks like Angular, Django, Spring, etc. Kiuwan also gives you 2 default models or bundles of rules, one called CQM and one called PHP Symphony. These are default models right out of the box, but the expectation is that you will create your own models over time. The 2 models that we give you out of the box, CQM and PHP Symphony, are preloaded with a general set of rules that are good to get you started with a general set of security and quality code analyses. And then from there, you'll create your own rules or your own models and pack them with your own rules. So you could take the model we gave you, for example, and trim it down or add more to it. Once you have set your application definition, like we did when we first started, and you assign it a model which contains rules, and you click go and start the analysis, Kiuwan analyzes your code and comes back with a dashboard of the overall security posture of your application. So the application definition that we created at the first assigns a model, its rules, and other parameters and metadata to each analysis. The Kiuwan rules are Java classes that are instantiated in a Java applet, and a framework that we refer to as the Kiuwan Local Analyzer, called the KLA. The KLA crawls over your source code looking for coding patterns per the rules and creates an analysis results file that is used in the Kiuwan dashboard, the cloud dashboard. We'll be using an analysis engine in the cloud rather than running the KLA on your local computer. Look for other webinars in the future from Kiuwan on how to run that local analyzer and leverage the full power of that local analyzer on your computer and on your domain. You saw earlier that introducing one of your applications to Kiuwan is as simple as clicking on the new button, just typing in some meaningful name. You'll have the ability to set some metadata, so additional descriptions. Pick a model. Remember, we said models are bundles of rules that are going to be applied to the analysis. And then you'll learn about this stuff a little bit later. That has to do with ISO 25000 and the importance of these parameters in our characterizing of this application. And then we'll talk a little bit later on the concept of audit and controlling quality of code being checked into your system. Once you define that, you can go ahead and submit your code, and then the analysis is run, and when it's complete, Kiuwan assembles additional information and analytics on the analyzed source code, and then makes all that available for you in the dashboard for review and management. So when that comes back, we start with the summary page for code security, or SAST. Code summary page is a good place to start to see the grouping of the vulnerabilities by severity, very high to low, and the estimated time to mitigate those vulnerabilities, very high to low, the estimated time. We won't go into the deep details in this webinar, but both the severity assignment, very high to low, and the remediation time budgets that we use or that we allocate for a given defect in the very high to low category is user configurable. So that is a vulnerability that's normal from my point of view, from a Kiuwan 15 years of experience point of view. For this particular app, may be considered very high in your world, and the amount of time that we allocate to remediate that issue may be too much or not enough based on your developers and skill levels, the source code experience, or other parameters in your team. Those are all user configurable so that you can go into a given rule and you can change whether you consider that rule very high or normal or low or whatever. And then you can change the amount of time you budget for your team and that app to remediate that given vulnerability. So as I said, out of the box, Kiuwan gives you that baseline of vulnerability rankings and remediation time estimates so that you can start to measure success and then fine-tune your responses from there. The code security files tab, once you complete your analysis, brings back a list of all the files with some kind of overview of their indication of their relative vulnerability health. More importantly is probably the vulnerabilities tab, which lists the vulnerabilities by class, by individual files, and then on down to the actual line item, complete with filtering so you can sort this list and manage it a little bit more easily. This tree view allows you to seek the proper, whatever depth it is that you want to go to view your code. You can drill down the vulnerability types, get down to the actual line number into that file, and then start to review that defect and figure out if that is something that is a candidate to be worked. We also have the ability in the Kiuwan terms to work smarter, not harder, and use the propagation path functionality of Kiuwan to see where a source issue is and where it propagates throughout your code. The idea here is that if you can, you would prefer to fix at a higher level and minimize some of the labor that you have to clean up your code. So recall we scanned code, we got a summary back, we get a large list of vulnerabilities, and we start to curate that list by muting. One of the powerful parts of Kiuwan is the action plan functionality. From here, we can go, let's pick an app I think that has more action plans. And talk about how action plans are subsets of the items in the vulnerabilities tab and are the managed list of tasks that will be pushed to whatever task tracking tool your developers use. So if it happens to be Jira, then there's some specific plugins, or you can put it into a flat file and mangle it that way. Creating an action plan, which is just a curated list of all the vulnerabilities that we're going to be working on in the next work period, is done by creating an action plan with what we would recommend as the what if tool. So Kiuwan has a feature called the what if tool that brings back the list of vulnerabilities from that analysis and then allows you to manipulate that list or curate that list down based off of parameters that you think are important. So for example, let's shift over to a larger application with more issues. So this application, a customer portal, has 1,500 issues. If we go to action plans, go to the what if scenario. And the idea here is that security types and even engineering types may go to a design meeting and decide that they have, in this next sprint, they're able to make available 20 hours to work on mitigating these issues. You can go to Kiuwan and click simulate. Put in parameters that you care about, 20 hours in this case, or you can also level up the stars. And that brings back a list of vulnerabilities that Kiuwan thinks should be worked on to improve the overall posture of the application. So in this case, that 20 hours spent would have reduced about 200 very high vulnerabilities if you did this list. We can talk at some other webinar about the notion how, because of our ISO 25000 roots, it's much more than just a simple parsing of the list based off of time, first in, first out, and it's a more complex ranking based on reliability, efficiency, and some of the other parameters of ISO 25000. Once you come to an agreement on what the next action plan will be, the to-do list will be, you can save that off. And then that becomes an artifact that you can manage. So you can see the defects. We'll show you later on some concepts under our audits functionality where you can manage this action plan as a quality control tool to control the quality of code coming in. So I want Sally Coder to work on these issues that are represented in this action plan, and then I can assign checkpoints and quality controls to make sure that the code that Sally tries to submit meets criteria that we've defined, or you've defined. And then from there, you can push those action plans out, either old school PDF, or like I said, if you have integrations, you can push it into your other tools. All right, so so far we've looked at the SAST portion of Kiuwan, the product we called Code Security. I have already hinted to you that we have our roots in ISO 25000, which is more about software quality and speaks in terms of 5 pillars of software quality. Those pillars being code efficiency, code maintainability, code portability, reliability, and then code security. And you've already seen code security because we broke that out as a SAST product. You might know these concepts of efficiency, maintainability, portability, reliability, etc. as code complexity, code smells, spaghetti code, code reuse, those kind of things. Kiuwan analyzes for those features in our code analysis module, but functionally it's very similar to code security. Vulnerabilities in code security shows up over here as defects, but it has the same layout, same function, same verbs. Action plans over in code security are still over here in code analysis, but instead of having one metric that you're balancing against, the metric of security in the code security area action plans, in code analysis you get to manage for a more complex or richer set of metrics or KPIs for your action plan, namely being the 5 pillars of ISO 25000. Both code analysis and code security modules have the same abilities to mute issues, and at the higher issue type level, the file level, and down at the line code level, as well as metadata about any given issue. So recall that code security has vulnerabilities, code security has defects. They all have this tree control where you can shift from a vulnerability view down to a file view, down to a line item view, as well as both code security and code analysis provide you with this metadata that comes back, including pages on whatever metadata we know about that vulnerability, including sample bad code and ideas on how to fix that code. Managing these ISO 25000 qualities will be very interesting and understandable to your security types, but most value when talking with the developers, DevOps, and dev management types. So look, there's a bunch of information in here on our functionality here in the ISO 25000 parts of Kiuwan, the code analysis part. So look for future webinars from Kiuwan on exploring in more detail how to pull the most power out of the code analysis sections. So earlier on, we uploaded some code and did an analysis. And so far, we've been talking about the SAST portion of Kiuwan with a shout out to the code quality portions of Kiuwan, which are closely related to the SAST tools. Now we're going to shift channels a little bit and talk about Insights, Kiuwan's SCA or software composition tool. It's used to step through your source code and analyze for third-party and open source packages. Insights returns a list of packages found and an analysis on package freshness, obsolescence, the licenses found, and security. The overall dashboard is much like you saw before, where you have some amount of filtering, a list of that gives you an overall high-level status of what we uncovered. The obsolescence tab presents you a view of the packages that we found and some kind of analysis of where we think they are in their freshness or obsolescence posture. That, generally speaking, comes down to a list of what package we found, the birth date of that package, the last time it was touched, and what version you use, and then your development team will be able to look through this and start to adjudicate whether there is a line of sight to replace this or upgrade this, or has it been deprecated and rolled into some other package, stuff like that. The licenses lists out the licenses we found that were encumbering your application. That's just a listing of all the licenses which we expect would seed a discussion with your attorneys and you and your engineering management team, and you could start to figure out whether you care about any of these licenses or not, including all the metadata that we may know about some of those licenses. The security tab is a little bit different from what we've been doing before. Code security and code analysis have been organized around the CWE framework, looking for common weaknesses. The security tab speaks more in terms of CVEs and CVSS for the security types. And the expectation here is that when you run insights on and review your third-party and open source packages, you'll get a reply back commenting on the security posture of those packages with respect to CVEs and the CVSS of those packages. And then the security types can help the software types understand what this means and curate this list into an actionable item for the developers. So please, Mr. Software Person, work on the following items first, or however you guys do it. So we created an action plan. We analyzed our code. We created an action plan or to-do list for the developers in code security and the code analysis tabs. Like all good developers do, your folks will start to code away and eventually try to check their work into the repo. When they do their pull requests, maybe you are branching your code base and then you assign per action plan some tasks to your developers. Hopefully you'll assign it to them as an action plan. Let's find one that we can look at. And then assigning this action plan to a developer, the developer starts to work on that. Maybe they have the Kiuwan plugin in their IDE so they can pull down the results. They code away. They try and do a commit or stage their code back into the repo. And what happens when we do that is that the developers check in their code via with labels, calling out the delivery and the branch and branch name that they used in the analysis and the action plan that they're using to monitor their work. And then that gets pushed into Kiuwan, and Kiuwan is smart enough to know that that application that we're analyzing, in this case I think it's not sure which application this is, but we assign to it that every application has the ability to be assigned an audit. So audits are checkpoints or quality control checkpoints that we create. So for example, let's say our developers is assigned the audit called Jack's audit. Jack's audit has a series of checkpoints that are used to measure the quality of the code that that developer is checking in. So it can either be per application or per individual. In this case, we're presenting it like an individual. So Jack, when Jack checks in code, his code has to meet the following requirements, the following checkpoints. It's a complex weighted score. So anytime this audit is run, it has to successfully reach a certain score to be considered good, to thumbs up. And that score is built by a complex weighting of the individual checkpoints and their contribution to the overall score and whether they're mandatory or optional. And with that, then you can apply that audit to an action plan that we created over here. And then you start to develop this Boolean flag that your CI can use to block or break commits or whatever actions you want to take on those flags. So that is to say, this developer tried to commit code and it got caught in the audit checkpoints, and it was measured and found that it had a score of 40 based off of those checkpoints that we created over here under audits, and threw a Boolean thumbs down, a false. And then later on, they submitted another response and it actually passed, so that's fine, but we had the option, if we wanted, that we could go ahead and override and that status and promote it, toggle the Boolean so that the CI could go ahead and accept it for promotion into the baseline. So if the code commit fails and fails to meet those quality goals, your CI is presented with a pass-fail flag that can be used to modify the workflow, break the build, or call for human override, as I said before. We don't have a lot of time to explore fully the power of audits and how you can use this to assert control over portfolios of applications or individual applications or individual contributors, whether they be a single human developer or a vendor that's contributing code. But it's a very powerful concept, and you can expect to see future webinars from Kiuwan where we specifically drill down into the CI/CD integrations and how to leverage the power of audits and checkpoints to raise the quality of code going into your repos. Now, one of the artifacts of being or having our roots in ISO 25000 is that we tend to see life from a holistic code quality point of view, which gives rise to the governance tab. Governance gives a view of the code-based metrics, risk, tech debt, quality, security ratings, etc., with an eye to groupings like individual applications, application portfolios, language code factories, etc. All allowing leadership to manage total quality from a higher level than the line-by-line issue list that you saw in code security and code analysis, and the package level that you saw at Insights. Look for other webinars from Kiuwan on the specific tabs here and how to pull some of the power out of governance and manage for effect on your application values, your tech debt, overall code quality of your pipeline and your code base. All right. So reviewing some of what we covered today, we created an application definition. So if we're doing code analysis or code security, doesn't matter. We created an application definition by clicking on the plus, uploading, filling in the metadata or information as necessary. We uploaded data via the Analyze tool, or you'll see in future webinars where you can use the Kiuwan Local Analyzer, which is the downloadable tool to analyze your source code on your domain. When the code finished analyzing, it came back with a dashboard with the overall summary, including the time. If we've run this multiple times, we'll start to develop a history, some overall analysis, and breakdown of what we found from a file level, and then more specifically down into the specific vulnerability type, file, and line item, complete with metadata on what that vulnerability is, so we can hopefully create some teachable moments for your developers, and they can improve their future efforts by seeing what is bad code, what is good code, and clicking out to learn more about these concepts if they don't understand what that vulnerability is. Then we took a look at Insights, which was the source code software composition analysis, and we analyze by components. And then we took a look at lifecycle, which is closely linked with the action plans of code security and code analysis, and a tool that you can use to manage or start to manage the branches or the work efforts of contributors pushing code back into the repo. And then I took a moment and showed you about audits, so you can put some quality controls on those efforts to push code in per a branch or whatever they're working on. And then we took a brief look at governance, which is that higher level overall view of the environment, taking a look at the activity of the code base at the organization level. We didn't spend much time today talking about the REST APIs that bring back most of the data you saw in these screens today for your own tooling. Nor did we talk about some of the data, some of the standard features you get with Kiuwan, like the reporting and data exports, or the RBOC and SSO user management panels, or the Java libraries from that KLA that you could run on-prem, so that you can stitch the KLA into your own engines or tooling to lend to them some amount of SAST and SCA capability. Look for, I encourage you to come back and take Kiuwan for a trial and poke around on those things, and or check out some of our additional webinars and canned videos so that you can see more about those functions that we didn't cover. Or you can actually drop it into the question Q&A panels and we'll try and field it there. And if you, like I said, if you give me a valid email address, we'll close the loop with you and try and answer your questions offline. So there you have it, a whirlwind tour of Kiuwan, but there's much more to Kiuwan than I had time to show you today. You can contact us for the trial, like I said, or a more personalized tour. So you can contact us via email, or you can click on some of those links. Find us on our webpage, where we have some of our blog content and additional videos that you can learn more about Kiuwan, as well as some documentation, user manual type stuff. And then we have additional videos on YouTube channel, so you can see some of us there as well. So with that, I think I'll turn it back over to my minions and start seeing what questions we have out there that I neglected to answer. Let's see, while we're waiting for some questions to percolate up. Is there a way to know the speed of an analysis? So how long does it take to run the code? So there is. So whenever we do an analysis, we collect metadata on that analysis, and that's accessible for each and every analysis. You can pull that down, and it gives you an overall timestamp on how long it took to run that code. But generally speaking, we don't have what it takes to tell you what it's going to take to run an arbitrary code, right? So you can't just tell me, yeah, I've got 5,000 lines of code, how long is it going to take? There's many factors that impact that. Processing speed on your side, complexity of the code, the language, etc. We had some questions about pricing models. So generally speaking, we work on lines of code rather than seats. So you saw how I answered or created application definitions. Those, when we upload that analysis, we count the lines of code, throw out all the duplicates, and then in the blank spaces, we have a more sophisticated deduping and line code counting type model, and then we go from there. And then if because we're at this hybrid SAST model, you can, if you end up busting your limit and having a large code base that you need to pass through, and you've overrun your limit, then you can bump up your levels. And then the analysis resets, the lines of code counter resets every 24 hours for an application. Now let's see what other questions we have here. IDE support. So yes, I touched on it briefly. All Kiuwan all the Kiuwan, how should I say this? Kiuwan has plugins for IDEs, and the IDE plugins we have for the Intella family, so PyCharm and those kind of things, Visual Studio and Eclipse family of IDEs pull the Kiuwan analysis down from the Kiuwan cloud into your IDE. So you can click in your IDE and open up the file and work on the code. If the developer wants to learn more about the specific default or defect, then they'd have to go to the dashboard. So all of them pull data down, put it into the IDE. Eclipse also has the ability to request or initiate a scan. So it's bidirectional, where the others are all unidirectional. All right. Let's see. What other questions are there that I may have missed? Trying to pull up some. Going back to the IDE, do you autocorrect the code vulnerabilities? So we don't currently have any IntelliSense or autocomplete syntax checker type functionality in those plugins that I was talking about. There are various enhancement requests to go that direction, but just generally speaking, for us to fix your code means that you give us a lot of power, and it's probably power that you don't want to give us, and it can be kind of noisy to you. So to be effective at fixing a given line of code, we need to know the whole code base so we can know what's going on above and below the code that's in question. And that's probably sharing more of your code with us than you really should be doing from a risk point of view. And it kind of assumes that I know your business more than you know your business. And trust me, that's probably not right. One on incremental analysis. Okay, so there's a question on incremental analysis. I'll see if I can pull it up so I can get the exact question. If I don't find it in time and exactly answer it for you, we'll email you and close the loop on that. But generally speaking, I showed you how to create a definition, upload the code, or use the Kiuwan local analyzer to analyze on your premise. It sends the results file up to Kiuwan, and we show you all the good stuff. So generally speaking, you start that first run with a baseline, and you analyze all lines of code. And let's say there's 150,000 lines of code. Then you create an action plan, you assign it to your developers, and they start to fix the defects. And then they request another analysis. So generally speaking, what happens is instead of requesting a brand new baseline, they will request a partial or an incremental analysis. And we step through the code again and we see what's changed. And then we just analyze that change. And it still could be 150,000 lines of code, or maybe it's 151,000 or 149 or whatever. But we're just working with the delta and analyzing for the delta. And then that modifies your vulnerability list, and then that gives your management an opportunity to go back through and curate that vulnerability list down into a new action plan. And then I see a question on roles. So we're RBOC. So rules are how we do access control. So we're RBOC. So you create user groups and roles, and then you assign individual users to roles or groups, or you can assign roles individually. And this is common. You'll see that in many of the Adira products that we're kind of groovy on RBOC. I think we're getting kind of down to the end.
Hello. This is Minion Luis speaking.
Yes.
I already answered a bunch of questions. So if anyone has more questions, please do not hesitate to do them. Sorry.
Excellent.
So back to you.
I would point out, I'm teasing Luis there, but Luis and I are both pre-sales engineers with Kiuwan, and as you may have detected from my accent, we service the world. So chances are very good we have someone that speaks your language, both from a software point of view and a human point of view, and in a time zone that works well for you. So don't hesitate to give us a call and put us through our paces. And with that, it's about 6 minutes till the top of the hour. I'll close by saying once again, thank you very much for sharing an hour with me. Look in your emails for a link for this webinar so you can share it with other people. Please do not hesitate to contact us if you have any questions or just want to get geeked up on software and software analysis, code quality. And look for future webinars and stay in touch. Once again, have a great day. We'll talk to you in all the usual places. Cheers.